Hello everyone, my name is Alicia Mormon. So today we are basically going to present our final demo for our course GPU. So basically our project is converting an image into the cartoonify effect. So as you can see, we have already showed you our CPU version in the internal demo. So what we have done is we have set up the opencv opencv into the Google Colab by using the following code. So basically, we are taking an online picture of the kitten and implementing our and transforming the image into the cartoon using the effects into the this kitten on this kitten image basically. So we are basically writing a file named cartoonify.cu and then implementing all of the code and all of the effect of the image transformation in that file, and then after that we are calling that file using the below code and then we are basically finally calling this output. So what we have done in the code is basically we have used the met function of the opencv, and then we have read an image of the kitten file, and then we have checked whether the image has been loaded or not. So this function basically gives you an error if the image is empty, or otherwise it will give us or tell us that we have already read an image. So after that, what we have done, we have used this image into our CPU function that is free to blur, which is basically converting the image into the cartoon and using all of the effect, which has the gray filter, blur filter, finding the edges and detecting the edges, along with the bitwise and operator and other operators, which I will be discussing soon. Okay, so basically this function is taking a parameter of the image which we have read earlier, and then it is taking creating an other mat image of the gray image, in which we will be basically we are converting and we are using this image and then implementing the gray effect filter and saving that gray filter into this gray image. So basically CV2 color convert an image from one color space to an other. So over here we have defined in which filter and which effect we want to convert an image. So we have converted an image into the color to the B2R VTR2, the gray image. After that we are using the Gaussian blur filter. So the image is convolved with a Gaussian filter instead of the box filter. So basically this filter, what this filter is do is it is basically a low pass filter that removes the high frequency component, which are already reduced. Then we are using the Laplacian filter, which basically is a derivative operator which is used to find the edges in an image. And after that, what we are doing, we are subtracting uh, 25 minus the from the edge image which we have been using. And after that we are using the threshold filter, which basically is the assignment of the pixels value in relation to the threshold value which we have provided. And after that we are using the edge preserving filter, which is basically a smoothing filter, which basically smooth an image, that is basically a masking of the image. After that, what we are doing, we are using the bitwise and filter. So this filter basically work this way that a bitwise end is only true when both the input have the value that is on. And if we talk about the CV2 bitwise end function, so basically it examines every pixel in the image. If the both have the value greater than 0, and then the pixel is turned on. And so what it returns is basically the bitwise end of the value for each pixel uh, of the input image. For example, take CRC1 or CRC2 image. So these are the input images. So it basically do that each so basically it's do the AND operator for the each pixel of the input images, and then that value that the output it get it that it gives the pixel value to the output image. So this is what the bitmice and do, and after that we are writing a file which is cartoon.png, and it is giving us the output for that. So basically we have also calculated the CPU time for it, which we found is this file. I will be showing you the output which we have received from this image. Moving forward towards this GPU function, we have done the similar thing over here, only that we have used the GPU functions of the opencv. So what we are doing over here, we are similarly writing a file in this function, um, finding the error and loading the images. OpenCV has a one benefit that we can use the GPU mat function, which basically serve as a primary data container. So basically, this function, this interference is similar to the CV mat function, which basically making the transition to the GPU module exactly as smooth as it is possible. So basically, GPU mat function is basically used for the GPU version of the OpenCV. So what we have done, we have call out this kernel of Cartoonify, and we are doing the exact same thing which we have done in our uh, CPU version, but this time we are using the GPU mat function, which is basically for the GPU function, GPU kernel. So what we are doing in this function is taking a parameter image that is basically reading the file. So once the image has been read, it is converting then again reading the file and then converting that into the IM grayscale. So before moving towards that, I would like to add that that GPU function receive GPU mat as an input and the output argument. So over here there are uh, two functions that are provided by the OpenCV for the GPU mat. So basically, it's transfer the data from GPU mat to mat and vice and similarly to vice versa. And there are two functions that has been used when we are using the GPU mat function, that is uploading and downloading. So uploads basically do this. It basically copies the data from the host memory to the device memory. So we are uploading this over here images, which is basically copying the data from the host memory to the device memory. And for the similarly for the download function, so download functions basically copy the data from the device memory to the host memory, and this is how we get our output in the GPU function and taking our time with the GPU function. Okay, so moving forward, what we have done so far is first we have converted an image to the grayscale. Now moving forward towards that, now we are using the create CLAHE, which is basically the contrast limited adaptive histogram equalizer. So basically it equalizes the image. So it is basically a variant of the adaptive histogram equalization, which take care of the overall amplification of the contrast. So this operation operates on a small region in the image, which is called the tile, rather than the entire image, and the neighboring tiles are then combined using the bilinear interpolation to remove the artificial boundaries. So basically, this algorithm and this uh, CLHE operator can be applied to improve the contrast of the image. Moving forward, we are using the median filter, which is basically the median blur. So this is performing the median filter for each of the source images. After that, we are using the adaptive threshold. Okay, so we were first thinking to convert our image into the we were uh, we were thinking to use the thread functions for all of the things, but over here the adaptive threshold, we weren't sure about the adaptive threshold. That is why we have to offer the OpenCV. So in GPU version and in CPU version, there is the only one difference to use the adaptive threshold. Uh, uh, okay, so in CPU version, we use adaptive thresh mean C, whereas in GPU, for basically this is particularly for GPU, that we use adaptive thresh Gaussian C to convert, to implement, to basically perform a adaptive threshold on an image. So this is the GPU version of the adaptive threshold. After that, we are detecting the edge. We are using the edge preserving filter, which is basically smoothing filter of the image. And after that, we are similarly using the bitwise n function. So for GPU and for CPU, it is same for GPU and CPU, this operator. And after that, we are basically downloading the image, which I said we are basically copying the data when we are downloading from device memory to the host memory. And after that, we are showing the cartoony effect. And this is what we have done so far. I'm right now showing you the output of it. Okay, so before showing you the output, this is the GPU time we got. And after that, we were wondering to use the thread function. So we tried using the thread functions, but the only thing we weren't sure about the adaptive threshold. That is why we have to move back towards the opencv for our GPU kernel. So we have already show you the median filter as well as the gray filter. After that, we have used the edge detector, which is basically detecting the edge of the images, and then using the Gaussian filter to in this function. But we weren't sure about the adaptive threshold. That is why we have to move back towards uh, the opencv. So now I'm running all of the output to see what I'm getting for my GPU version. So this is what I've got, and the output is over here. Okay, sorry. Okay, so this is the output. This is the output we got from the image. That is this. This is the image, and this is the output which we got after using the effect.
Hello everyone, now I will be going over the research paper that we have done, and basically our topic was cartoonification of images, and we chose this topic because we see animations being added and frames and filters being so extensively used on social media and basically everywhere nowadays. Also, we found the topic very relevant because of the coming of um, things like the metaverse and animated movies and social media, etc. We think that this is a very, very good topic to explore, and also there's a lot of future scope in it because the animation and the graphic design industry is already buzzing. So we decided to go ahead and try this on with our learnings in the GPU course. So basically, we start with an abstract which introduces why we have chosen to do this paper and what was the need of this project that we felt we should do it. In this paper, we basically propose a solution to transform real world images into cartoon style images. Those images can be people, or those images can be objects or scenery or whatever it is. It covers a wide range of possibilities. And our solution was basically to stylize these into a cartoonified form. And we have used functions like the Gaussian filter, and um, we have used laptation and thresholding, etc. in the project. So this is the introduction that you can go through. Then we have explained our objectives. Then we come to the literature review. We wanted to keep our literature review a little extensive because there has been a lot of covered in this topic in the last at least 12 years. So we have gone ahead and we've covered from I think 2007 to 2020 in our literature review, and the following were included. Non-photorealistic rendering was there. Then transformation for image flattening was another methodology that has been used. GAN model-based conversion has been used. Machine learning algorithms have been used in extensive projects with different approaches. So we've covered all of them, and we've explained how they are different and what their weaknesses were and what their strengths were. Then we talk about our algorithm, which explains the basic working of our model and our work. And then we have discussed our challenges, and we've given a summary and future scope as well as the references. So that'll be all. I'll just go into a little bit of detail of what out of our literature review we find was interesting and different. We have used the image being used is convolved with a Gaussian filter instead of the box filter. And the Gaussian filter is basically a low pass filter that removes high frequency components, and the noise is reduced. Noise meaning that it reduces any abnormal, highly bright, or very dull areas to smoothen out the image. And we have also used the Laplacian operator, which is the derivative operator, which is used to find edges in an image. And it converts and computes absolute values, and the results are always 8-bit. So we also did contrasted limited adaptive histogram equalization, which you'll be able to read about in the paper. So that'll be all. Thank you.